A method of control and data collection was developed to manage the DSMS experiments and to form the platform for initial automation of this process. The software and electronics to do this control are based on the Raspberry Pi. And the software is divided into 7 primary packages, all connected to a proxy server. This is designed to operate over the network, and so each of these software packages could be running on a separate machine. They can all be running on one machine, machine being either the Raspberry Pi or a PC, a Mac, or a Linux device. But they all timed together, and so we can add or modify any package to increase functionality or to modify the existing functionality of this program. This architecture allows these applications to be run remotely from any device, anywhere, basically, I guess, in the world. And these images here will show screenshots and video of the device in operation. You can see the red lines there and the white and blue lines are all image recognition driven. In other words, we just put the camera field of view over the needle and these lines are drawn automatically. You can see the vertical line there will begin to expand as the pump is turned on, like now, the bubble's growing. It'll monitor the size of the bubble of water, the droplet, and when it reaches a set droplet size, we turn off the pump and then we turn on the high voltage and spray the droplet away. And this process can be repeated over and over indefinitely, and the data then gets logged to be put out into an SQL database. And we're currently using the freeware database DB browser for SQLite to query the data. The data can be readily accessed from any machine using the freeware software called ODrive. This is a Windows or a Mac application that can easily link to the chosen file storage directory on any machine. Right now it's on the Raspberry Pi. So there's a few easy commands that you could use on a Mac computer or a PC computer for that matter, anywhere that would bring up this screen. And so from Australia you could be controlling the experiment in this lab with this interface right now today using the screen where you can turn the mode on to either auto or manual, so you could spray the droplet at any time you wanted. This shows the SQLite database browser recording the data, and you can see where the droplet begins to grow, grows up to a fixed size, high voltages come on, and it drops down in size. Of course, this data has just been taken during the development of the program, so it's not very consistent from plot to plot. You can see here where the control software has been looping for several hours, and data was collected automatically. Time hasn't been yet taken to experiment significantly using these tools. However, in the development of the tools, some observations have been made. First, in that the droplet size control is quite robust. That is, the image recognition is able to accurately recognize the droplet size over the range of interest. Secondly, in spraying methanol, periodic bubbles have been observed. And you can see these identified by the regular dips in the data. The cause is uncertain, but heat from the lamps or the surroundings is suspected. The high voltage spray time has been steady over a time frame of several hours, but we've noticed significant changes in spray time from, say, like 50 seconds down to less than 5 seconds during different points in the project development. We're not sure what's done. We've fiddled a bit with the specific voltage and the gap, but currently we don't know what the cause of that variation is. Fourthly, are continuing to notice that the Taylor cone direction is highly variable. We noticed this, of course, in the initial experiments with the droplet spraying off the droplet on the end of the needle, and that's yet something to be explored. Probably the mass spec instrument will tell us whether or not our data output is actually going to be affected by that or not. Now, we believe that the tools have been developed to the point that Andy can readily support them remotely. However, the time with Andy here on the site has been extremely valuable, and we expect that Andy will be asked to return to the lab from time to time.
All right, go for it.
Ready to go.
Andy's curiosity got him to poking around with the DNA robot. He was able to locate a friendly source of help at Qiagen that helped us find the current version of the software, configuration files, and the proper interconnects along with the developer's guide for the software. So this has resulted in making this robot now a viable resource for automating the DSMS experiments with the mass spec instrument. And Zach has been able to program the robot already to make moves that are representative of those necessary to produce the automated mass spec interface that we will need. Further, Andy has taken a closer look at the documentation for the Shimadzu HPLC pump and controller, and he believes that we have much existing potential here to automate this device as well for our process, a lot more than I expected in the beginning. All in all, it's been a very productive 10 days having both Andy and Zach working together in the lab. And the next steps here to finalize the preparation of the room for the mass spec instrument and to attempt building the trapped emitter using the Millipore monolith. Hopefully with this process and hooking it up with the mass spec, we'll be able to get some vitamin D or vitamin D analog and dilute it sufficiently to represent what we're targeting and see how well the mass spec can collect this data.